All right, good morning, everybody. So I'll send out another announcement, but I resolved our issue, sort of. I tried to add some content from a second book, trying to slow us down a little bit, and I managed to break Cengage/Blackboard, the interface between the two of them. So we've been working on getting that corrected. So I've changed some of the assignments around. We're gonna scale back a little bit and start a little further into the beginning. So bear with us as we work our way through there. So what I want to talk about is Python and some of our pieces that go with it, some programming constructs, and then we'll actually look at how we're going to do some of those in the labs, and hopefully that will help everybody out a little bit. So we talked about algorithms a little bit, and we said there's a difference between data and information. We talked about hardware and software, that random access memory, how the computer models data, and again it uses that simple idea of zeros and ones. A computer is nothing more than a series of light switches essentially that go on and off. So we talked about system software. We looked at a little bit about that, things like applications. We talked about the difference between high-level and low-level software and how this software works. So we create it with a text editor. It's translated by some kind of tool. So our high-level language gets sent into binary so that the computer can actually operate it. We looked at this really brief history of how the world has changed. And so we went from no computers to we've got some pieces that work very much like a computer to now we're all carrying around a supercomputer and we do everything on our phone. And it's changed our world a little bit in terms of how we operate and how the world functions around us. So first thing, before we had anything else, we had this idea of an abacus, and most of you have probably seen those. We had one of the first ones as some kind of computing device was a weaving machine that would automate the weaving device. So an abacus on the top. So there's our automated weaving machine, and it would do patterns, and there was a model for how those patterns are going to work. So way back in the 1800s, 1700s, we invented something called the Analytical Engine. And then we had a machine that developed for the census so that we could grab that data from the census even quicker. Other things you're going to run into, so we talk about Boolean logic. So back in the 1800s, we started this idea of how our logic's going to work. And then you'll see the term Alan Turing, and Turing still shows up today with something called the Turing test of whether a computer actually has the ability to learn. So other things that you're going to run into, terms you might see at some point. So von Neumann was a pioneer. You also see him in a lot of science fiction ideas, something called a von Neumann machine. In other words, it's a self-replicating machine. So in the 40s, and really we talk about that pre-World War II, World War II, we started to throw a lot of money into these things, trying to use that computer to solve some of our issues. The original mainframes were huge, giant rooms full of vacuum tubes. They put off huge amounts of heat. They took a lot of electricity. And yet they weren't as powerful as a calculator that you can go buy for $4 at the dollar store right now. But we've progressed. We've moved on. But still, some of those remnants are around. And one of the remnants is that large computer centers still use a large amount of power. The reason Google and Yahoo and Facebook tend to place their data centers where they do is for two reasons. They have connectivity to the world, so a lot of fiber optic cables, and they have cheap, reliable power. So that ends up with Council Bluffs being the only place in the world where there's two Google data centers in the same location. So when we first came out with these programs and we started to look at it, we actually used something called a punch card. And most of us have not seen or had to use a punch card, but a punch card was literally a piece of paper about half the size of a notebook sheet, and you would punch holes in it. And those holes would get red The computer would read those and then would operate a program based on that. So we started with that idea. We started to use some high-level languages and something called a compiler. So a compiler is a little different than an assembler. An assembler says, I'm going to run this program code you just put in as is. A compiler takes the code you put in and it compiles it or translates it into machine code. So if I do write something in machine code, it would run directly. If I use something to compile it or break it into machine code, that's a compiler. So when we talk about Python, we'll talk about how it works as a compiler. So high-level programming languages started coming out of there. Fortran, which we still use. Lisp, still used. And COBOL, which has fallen out of favor, but a lot of businesses still have tons of applications written in COBOL that are still running even today. So the banking industry, for example, has a lot of stuff in COBOL still floating around. So late 50s, we started to move to the transistors. Transistors were much smaller than a vacuum tube. So think of going from something the size of a cucumber to something the size of your pinky nail. Much faster, much smaller. In the late 60s, we even got integrated circuits. So we put more than one transistor on one piece. And we landed in there. A guy named Gordon Moore worked at Intel or was one of the Intel founders. And he came out with a thought that about every 18 months, our computer power is going to double because we're going to make them smaller and faster at about that pace. And so far, we've still kept into that, even today. About every 18 months, our power evolves. So, a couple other terms you may see. The idea of something called batch processing, and we still do batch processing. So things inside of MyPSC are batch processed. In other words, we wait until we have the computing time to do that, and they're processed at night or when the system isn't used heavily. Time sharing. Well, we still use time sharing on a lot of our computing systems. It just happens so fast that you don't realize you're sharing time with others. And then the idea of concurrent processing, or processing multiple things at once. Our new computers now have multiple CPUs, and we're able to do a lot of this concurrent processing. So we can do two things at once, literally, on a computer. We have to have the appropriate software to break it into pieces, but we can use that to break that up. So, first personal computers out in the middle 70s, things like the Altair. The original Apple came out in the late 70s, the original Apple I. And then, in terms of importance, in the early 80s, this poor little guy named Bill Gates and Paul Allen, well, they really borrowed a lot of code, but they're credited with MS-DOS. And from that, we ended up with Windows and huge fortunes. So it really has grown from that. So in the early 80s, if I wanted to use a computer, it was really only on a screen where I could only type. There wasn't the idea I could move a mouse around and graphics. So the Ethernet, which is what we use to connect computers, was invented. And the ARPANET, also called DARPANET at some point, was developed by our Defense Department. And that's where the Internet grew from. So really quickly, we're giving the quickest world as we can about that. We invented the WWW, World Wide Web. So the original internet was not graphical. Berners-Lee created that idea of multimedia and the idea of being able to jump from link to link. And so now we have web servers out there. We have a web browser or a web client, and our world has changed. We no longer store data locally in a lot of cases. It's all out on the internet. The idea of this client servers, so e-commerce kind of moved in, and people started creating a lot of content where we could store things on a computer, but that computer was stored on the internet, and we could build a bigger, faster computer on the internet than you could at home. And then we came up with Sergey Brin and Larry Page, so the founders of Google. They developed originally a search engine that could go out and search across all these pages on the internet, find them, and index them to display the results. If we didn't have a way to search the internet, it wouldn't be a lot of good to us. But we moved on. We created search engines, and then we had all kinds of other new things that have evolved. So one of them, and I think Apple is really the idea of the iPhone has been their biggest influence in there. Because before the iPhone, we had phones that would do a few things, but the iPhone was one of the first what we were going to call a smartphone. And in fact, they invented the PDA, but it was kind of a failure, called Newton. And then other companies a few years later came up with some PDAs. Then as we got in where we're connected, the idea of these social networks came in. And now one of the terms we see a lot is this idea of big data. So huge amounts of data. Companies store all these data about people, places, things, ideas, thoughts, things that have happened. How do we start to manage that data? So computer programs have been around for a long time. What would be nice is if we had programs that were fairly easy to use. And so Python is one of those programs. General purpose, it's very high level. In other words, the sentences that we're going to write look very much like English sentences. Python.org is probably the best repository of everything you could learn about Python, but it's not always easy to use because it does have so much information. But Python is a really great language to learn, but it can also drive a lot of development. So internally, a lot of companies use Python as scripting languages. In other words, I can run tests. So Google uses Python extensively with their staff. They'll use it to monitor what's going on in their servers. On the other hand, I can write entire applications. So we've probably heard of something called Dropbox. Dropbox was written entirely in Python. So it bridges from low level to high level. So we need some terms about Python. So we're not going to make you launch idle yet. So idle is that environment, Python's native environment. We're going to work inside a Cengage, but I will show you what it is. And then in the next couple of weeks, we'll show you how to create idle and how you can install this on your computer. One of the really good things about Python is we can put it on almost anything. So if you have an Android tablet, you can get a version of Python to run. If you have an iPad, I can make it run. A Mac, yep. Linux, yep. Windows, yep. Raspberry Pis, yep. Arduinos, yep. Just about everything we can get some kind of version of Python to run. So Python has some terms we need to look at, and you'll see these come across repeatedly, and that's something called the shell. The shell is the first thing we're going to talk about. And I will actually show you here. I have a slide of it. So this is what that Python shell looks like. So it's not very exciting. It tells you what version of Python. Here we can tell that this was done on an Apple of some sort. And we can see that shell. Well, I can do the same thing on this computer because I've installed it. And so see which window it's going to pop up in. Magic, always the wrong one. So here is the shell on this particular computer. And so this will look very similar to what you have. So notice here, this one is a 32-bit on Windows 32 machine. So it tells us a little bit about it. This version is 3.6.1. So major, minor, and update releases, if you want to think about it that way. So 3.6.7 is newer than the version they're showing here. And so this shell, I can run things at the shell level. So I can do a print statement. at the shell, and it will run that statement right away. So the shell is handy for short little lines if I want to try something like that. It doesn't let me create a very large program, and so that's the downside of the shell, is I can test out statements, but it's not very good for running entire programs. So the shell is where things will actually run, however. So here's an example. They talk about statements. So here's a print expression, just like what we did. So we put print, and we put in hi there, and it actually prints out. So this model says, hi, I'm going to take in a name. We take that name and we print it out, and we can actually print out that name, Ken Lambert. So we're using a variable. So name is a variable. We're putting a name into that. So enter your name, and you typed in Ken Lambert. So Ken Lambert becomes that value stored in name, and then we can print that. Very easy to do, and we'll show you again how we can do those. So we need to quickly go over a couple of things about Python and some quirks and oddities. So anytime I do an input in Python, it's input as a string. So we have two different basic types of data that we can use in Python. So we have a string, which is a group of characters, and we can have some kind of a mathematical model or a number type. So if I input something, it's input as a string, always. Well, a string, then we have to convert it if we want to use it as a numeric expression. So if I say, please input your age, when I put in 51, when I put in 32, 32 sounds better. When I put in 32, that 32 is a string, and I have to use a conversion to convert it into either an integer or what we call a float. So we have two basic data types. We have strings, and we have some kind of a math notation. When we have a number, we typically have in Python either a float, so in other words, it's got a decimal point in it, or we have an integer. And so an integer doesn't have a decimal point, it's just a whole number. They're both useful for different purposes. One of the best things with integers is they take less room to store. And so if I'm using something that doesn't need a decimal and I use an integer, it works really, really well. So we can show you what some of these would look like. And I'll show you where we can practice those in just a second. So here we have that idea of we've got to enter the first number. And notice this little int standing for integer. So these are all, you can think of this all as functions. So everything inside of here, go backwards. Everything inside of here is passed into the function integer, and everything inside of here is passed into the function input. So input our first number, 23, input our second number, 44, and then it will say the sum is first plus second. And then the sum is 67. However, if I had just tried to add those together without doing that, I can actually show you what that would look like. And you can see what kind of error you might end up with. So we can do the same thing. So first equals input. And notice I'm leaving out that conversion. First number. And so I'm going to put in 23. And then I'm going to put second equals input so pardon my typing if I do anything really weird here. So second number, and I'm going to put in 43. So now I want to print, and we can put those additions right in there. the sum of those two numbers is first plus second. Now, when I hit this, let me move this up a little bit. You would think it would add those two numbers, 23 and 43, but let's see what actually happens. Oh, so when I didn't convert them to numerical values, what happened then is it just adds them together. It puts 23 plus 43 and concatenates those two together. Well, if I had strings of text, that may be what I wanted, but since I left out that int, or that convert to integer, it did exactly what it thought it should do with those numbers. So, and as we saw, those weren't then numbers. So we do have to be careful, and we can process those. So these are some of our conversion models. So float converts a string to a float. Integer converts a string to an integer. Our input says, I want to take something in. Our print, and then we can add those two together. So our plus key is a really, really good extension for doing that. All right, so I'm going to stop here for a second, and I want to go to into our Blackboard shell, and I want to look at Programming Assignment 1.1. So I open up 1.1. Now, it may require you, when you click on this the first time, to reassociate and re-put in your information. Hopefully it won't. But start assignment now. And so I revised these assignments to hopefully make them a little easier and get everybody familiar with how Python's going to work here, as it slowly creates our sandbox for us. I did mention slowly. Did yours pop up yet, or is it still spinning? It takes it a while to load for some reason. So off campus, I notice it loads significantly faster. Let me try that again. Nope. See if it will load. Did I mention that I broke Cengage the other day? Because that seems to be